So here we have a solid lying between the planes perpendicular to the x-axis from x equals 0 to 6. And we know that the cross-sections are squares that go from the x-axis up to this curve right here, which is just the square root of x plus the square root of y equals the square root of 6. And our goal is to find the volume of the solid. So V, the volume, is just going to be the sum of all of these squares, the cross-sections. So to do that, we have to use an integral, and we're going to go from x equals 0 up to 6 for this integral. And for the squares, we're just going to use s for the side length, and then we have to square that to get the area of the square. And then this will be times dx. And to find s, well, all I need to do is solve this equation right here for y, so that I can get an equation for the side length of the square. So if we know that the square root of x plus the square root of y equals the square root of 6, to solve for y I can subtract the square root of 6 on both sides and subtract the square root of y on both sides, and I'll end up with this. You could have also just subtracted the square root of x on both sides, that would have worked too, and now I can just square both sides to solve for y. So as you can see on this side, when you square negative square root of y, you still get positive y. And this I will just leave alone. So this is the square root of x minus the square root of 6 squared. So that's basically this right here. I could have even put down this s as a y. And of course, you can't integrate this. You have to plug this in, because this integral is in terms of x. So we know that this is going to be the integral where x goes from 0 to 6. Now I have to plug this in and square it. So when we square the square, we're going to get a fourth power. So this is going to be the square root of x minus the square root of 6 to the fourth power dx. And now how can we do this integral? Because, we could expand this. It would be a fourth degree binomial expansion, and then we would just have a bunch of power functions. We could find antiderivatives and plug in numbers, but that would take forever. So we're going to do some calculus first to help us with the integration, because sometimes calculus is better than algebra. So I'm going to do a u substitution, and I'm going to let u equal to the inside right here. So I'm going to let u equal the square root of x minus the square root of 6. And now I will differentiate both sides. So du equals, well, the derivative of square root of x, the square root of x is like saying x to the 1/2 power. So you put the 1/2 to the front, you get 1/2. And then you have x, you have to subtract 1 from the power. So now you have x to the negative 1/2, which I will put as the square root of x down in the denominator right here. And then the derivative of this constant is just 0, so I will just put down the dx right here. Well, I don't have anything to cancel out with this. So let me go ahead and solve for the dx. I'm going to multiply both sides of this equation by 2 times the square root of x. So I'll just do that on both sides, and you'll see that these cancel, and we get that dx equals 2 times the square root of x times du. And now we can start rewriting this integral in terms of u. But the first thing to notice is that x goes from 0 to 6. So we have to be sure to put those values in here to get the corresponding u values. So if we put in the 0 right here, square root of 0 minus the square root of 6, u will start at negative square root of 6. And u will go up to what? Well, put in 6 right here. Square root of 6 minus the square root of 6 is just 0. So u will go up to 0. And then here we have u inside, and then we raise that to the 4th power. That's this part. And then the dx is 2 times the square root of x times du. But let me leave a little more space here, because we're having trouble here. We have the square root of x, but we're in terms of u. But I can use this to solve for the square root of x. Just add the square root of 6 on both sides, and we get the square root of x equals u plus the square root of 6. And I can substitute that in right here. So let me just erase this, and plug in u plus the square root of 6. Alright, and now we have something that's much easier to integrate. So we have these three factors being multiplied together, actually four if you include the du, and we see that this one is a constant multiple, so I can put that all the way to the front of the integral. And then I'll put down the integral from negative square root of 6 to 0 of, we have u to the fourth power, and then we have to distribute that into here. So u to the fourth times the u is going to be u to the fifth power, and then u to the fourth power times the square root of 6 is just going to be the square root of 6 times u to the fourth power. As you can see, now we only have two power functions that we have to integrate. So we can just do that really quickly, 2, and then I'll open a bracket for the result of the integration. So when we find an antiderivative for u to the fifth, I will just use 1/6 u to the sixth. And then for this one, we'll have the square root of 6, and then an antiderivative for u to the fourth is going to be 1/5, so I'll divide this by 5, u to the fifth. And here we can plug in negative square root of 6 to 0. So when we do that, 2, we'll plug in 0, and both terms give us a 0 when we do that. So I won't even put that down. But then we have to make sure we subtract what happens when we plug in this one. And let me do this in a different color so we remember that we're subtracting this whole thing right here. So plug in negative square root of 6, we're going to have, perhaps I should look at negative square root of 6 as negative 6 to the 1/2 power. So we're going to have 1/6, and let me actually put the 1/6 down as 6 to the negative 1 power. And then we have u, which is negative 6 to the 1/2 power to the 6th power, plus the square root of 6, which I will also put down, and let me just put down the 1/5 first. The square root of 6 is 6 to the 1/2 power, and then we have to multiply by negative 6 to the 1/2 power, because that's going to be our u value, and raise this to the 5th power. And let me put down a closed bracket right here, because we're subtracting this whole thing. Alright, so we have basically 2 times negative 1 times all this. So I can put down a negative 2 all the way in the front, and then just work out this part right here. So let's see. We have a negative, but we have an even power, so we know that the negative doesn't matter. 6 to the 1/2, when you raise that to the 6th power, you multiply the exponent, so 6 times 1/2 is 3. So I have 6 to the 3rd times 6 to the negative 1, so we just add the exponents, and we get 6 squared, which is 36. And then we have plus 1/5. Well, negative, when you have the odd power right here, we maintain the negative, so let me actually put that down first. And then we have the 1/5. Well, 6 to the 1/2 to the 5th. 5 times 1/2 is 5 halves, but then I have to multiply by the 6 to the 1/2. So again, we add the powers. 5 halves times 1/2 is, well, 5 halves plus 1/2 is 6 halves, or 3. So we're going to have 6 to the 3rd power, which is just 2/16. And now we can just work this out. So we have negative 2. 36, I'm going to put that as 180 over 5 minus 216 over 5. So we have negative 2. 180 minus 216 is just negative 36 over 5. Negative times negative becomes a positive 72 over 5. And I will just put this as the answer in the back of the book, which is in decimal form. So we have, well, 72 over 5, 70 over 5, it would be 14, but then we have the extra 2/5, which is a 0.4. And this is the answer in the back of the book.